Hello and welcome to this tutorial on assembly language coding of 8085. The first and simplest program that we will understand is addition of two 8-bit numbers. So for example, what we are doing over here in this code is we have a number into a location. Say the number we have is into 4150 hex, and we have another number into a location that is 4151 hex. Let's just assume that the numbers are 10 and 20, and we just simply doing addition, and the 8-bit numbers ranges from 00 to F hex. And for example, we had FF, and if we just keep on adding it, then it might result that the number, for example, 10 plus 20 is 30, so it's an 8-bit number. But there can be a case, for example, if we add two other numbers, that might generate a carry. So we need to store the result into 2 bytes. The first one is LSB, lowest significant byte, and this is MSB for carry. And what we are doing is we are storing LSB into 4152 hex, and we are using 4153 for MSB or carry. Simply you can say that. Okay, so this is what we are trying to achieve. We have two numbers into memory location. We are adding it and storing it into third location, and storing the carry or MSB into fourth location. So let's just understand how it works line by line. So here's the thing. MVI C, 00 is the first line. What we are doing is we are clearing C register with 00 value to use it further in the program. Then we are loading first value LDA 4150 hex into accumulator. So we are loading this value into our accumulator, right? So accumulator value will be updated with value of 10. Then we are shifting this value to register B. So register B will now have the 10, the first number. We are loading it here and then shifting it into B register. Then we are loading accumulator value with the second number. So now we are loading this thing with 20, right? We are loading this thing with 20. Now we have our first number into register B, our second number into register A, and now we will simply use add B. So what this will do is it will just simply add B to A and store the result into accumulator A. So now the accumulator value will get updated to 30 because 0 plus 0 is this and 2 plus 1 is 3. Simply, there is no carry into this particular instance or test case. Now if we do not have carry, that is jump if not carry, then just simply jump to this thing. So then what we are doing is STA 4152 hex, we are storing this value into a memory location with address 4152 hex. So we have 30 hex into our memory location 4152 hex, and the next line is move C to A. The value that is the carry is now moved to A, that is now A register is 00 as we do not have any carry into this operation, and 4153 hex, 4153 hex is now 00. But if in case we had a carry, it will be stored into this location. So the things are pretty much clear over here itself, but to better understand, what we can do is we can use a simulator to see all these things, or we can just directly use a kit and run this program and see each and every register value as well as memory location value. So here what we are going to use is this particular thing, that is 8085 simulators gnusim8085, right? So let's just clear all the drawings. So here is a simple interface of this thing. It is an editor over here. So the editor, here you can see all the register and internals. A simple decimal to hex and hex to decimal converter is given over here. You can update IO port values from here, and you can update memory values from here. Here you can view all the variable and data. All the stack data will be shown here. A simple keypad of all the instruction of 8085 is given here. So if you don't remember any particular instruction, you can simply load it from here. And you can monitor and check various address values from here, IO port as well as memory values. And the basic is step-by-step instructions: step in, step out, and step over, a breakpoint insertion. And the commands can be run from here also: step in, step over, and step out. You can assemble the program using F8 and execute the program using F9. So what we want to do is we just first want to load our two numbers into 4150 hex and 4151 hex. So let's just do this thing: 4150, and we want to give value 10 and update the memory location over here. Basically what you would want to do in ideal condition is reset all the registers first before starting anything out. So everything is now 00. Now update this value with 10 because we want to take first number as 10. But here nothing happened. We are not able to see any data into 4150 hex memory location. So what exactly happened is 4150 decimal, let's convert it into hex. We have a location of 1036. Let's just move to this location and check whether the data gone to this thing. So yes, whenever you are inserting a memory value, you need to input address into decimal number system. Okay, you can't just simply put H here or insert something like that. It is not possible. This is specific to this simulator, so keep it in mind. Many times I have seen that students do this mistake, so keep a note of it. So what we need to do is just simply go to this thing, that is 4150 hex, and here the address in decimal is also shown here. So we just simply need to input it over here, 16720, and then update the value to 10, and here it is, right? And for next number, that is our 4151 hex, we want to insert a value of 20. So 10 and 20, we have our inputs ready, and then what we can do is we can simply run the program from this button or directly from this execute menu or directly by pressing F9 key. And let's just do this once. So yes, 10 plus 20, the result is into 4152 and 4153. We have LSB is 30 and we don't have any carry in this case, so it's 0s 3 0 simply. That's it, a simple thing. You can just check the results are same and the code is working perfectly fine. But to better understand, what we can do is we can just run this program step by step. So let's just first of all reset each and everything. So everything is now 0 0 again. We need to again update the values 10 to 4150 hex and 20 to 4151 hex. So now just press this thing, MVI C, 00. This line is highlighted, means the next line that the simulator will execute is this line. The program counter is currently pointing to this particular instruction. So after this, what we expect is C to be 00, register C to be 00, but it is already 00, so we will not see any change. But yes, PC got updated, so the simulator highlighted it with another updated address location. Now this instruction LDA 4150 hex, so we are expecting that this data will be moved to accumulator. Let's just check it. So yes, accumulator got updated, but we had 10 and it got updated with 0A. The reason is simple. Decimal, you can see it over here, and here it is showing as hexadecimal value. That's it. So now the next instruction will simply move this to B. Let's verify it. So yes, it got done. Now we are loading a second value, that is 20 into accumulator. Let's see that. Yes, accumulator got updated with 14, a decimal, a hexadecimal equivalent of this thing, right? 20 in decimal is equivalent to 14 hex. Now what we are doing is add B, add this with this with this, right? 10 plus 20. So the result is, let's just see that is it correct or not. So 13 decimal is equivalent to 1E, right? So we have our result into accumulator. It's not yet into memory location. We loaded both the values into accumulator, A and B. Then we simply use these instructions, and the result is now into accumulator. Now if we don't have any carry, which we can check that we have carry or not. So we have no carry over here. So we are expecting the program control to move to line number 18. So let's just verify this. Yes, line number 16 just got skipped, and line number 18 is currently pointed. So the last part of the program is simply doing storing the result back from registers to memory. So yes, STA 4152 hex, accumulator value got shifted to 4152 hex, that is our 30, and then we will load the C carry value into accumulator, C register value into accumulator. So accumulator has 00 now, and we are shifting or pushing this 00 into 4153x. It's already 0, so no impact on that, and we are now simply just holding the execution. So that's it. So this is how you can verify all these things. Let's just quickly take another example and verify our thing, that what happens if we got carry, right? What happens if we got carry? We can just simply do is, we can use 100 and 200. The result is 300, which is greater than 255. So it is definitely not an 8-bit number. So let's just quickly do these things. First of all, reset these things to 00. Everything is 00 now. And the first value we want is 100. So we loaded it with 100. The second value we want is 200. So this is it. Now let's just run the program step by step first. So yes, LDA 4150. So 100 decimal, let's just convert it into hex. It is 64, got loaded into accumulator. Everything is going smooth. Shifted this 64 into B, loading the second value into accumulator now. So 200 to hexadecimal, that is C8. Yes, it is right. Now we simply just doing 100 plus 200 decimal and 64 plus C8 hexadecimal, and storing the result into accumulator itself. So it is 2C. Let's just verify this thing, that 300 to decimal, it is 1 2c, right? We got our 2c into accumulator, and our MSB of 1 is now reflecting into carry flag. So if we do not have carry, just jump to this thing. But in this case, we have a carry. So what we are doing is incrementing the register C with value of 1. So yes, our program did not skip this time. We are now into line number 16. And we incremented register C with 0, 1. So we have our result, like this is MSB, this is LSB. Now we need to shift this result back into our register. So it's simply just shift the LSB from accumulator to for152 hex. So yes, it is showing as 44. Let's just verify that 44 is 2C, right? So we got our 2C into here, and now moving C to A. Yes, now accumulator is having 1, and then shifting this thing into for153x. So we have 1 and we have 44, that is 2C. So 1 2C, and let's just do one thing. Just convert this 1 to C, and yes, we have 300. So 100 plus 200 is 1 to C, that is 300. And this is how you can actually use this simulator to clear your concepts, and you can better understand how instructions work, how data can move from registers to memory, and how the flags really help, and how hexadecimal and decimal conversion and memory parts and everything. So that is it for this tutorial. Hope you got all the idea how simulator works and how simplest assembly language program looks like. So that was it. Thank you so much.